Welcome everybody on this short presentation on natural language processing. So just a quick introduction on Brainjar. We are an AI as a service company. So we build AI-infused applications for other businesses. That's our main focus. We do this across many different subdomains of artificial intelligence. But over the past few years, we did get somewhat of a specialty in natural language processing simply because the underlying algorithms developed so quickly over the past few years, and because we really see that with this increase in performance, there is also a very big increase in demand for natural language processing applications. So Stefan already introduced me. My name is Deevid De Meyer. Yes, it is written like that. It's not a joke. It's simply to enforce the English pronunciation. And I am the co-founder of a company, of the company called Brainjar, which I described earlier. So my apologies, people. These slides are going to be in Dutch, but it's not about the slides, what I'm trying to tell you. So I will be sure to translate everything that is important on what I'm trying to show. So first of all, let's try to answer a very important question, namely, what is natural language processing, right? We're going to try and give some kind of definition. I know it's a bit of a cheesy way to start a presentation, but it gives us a good point to start a discussion. Natural language processing, or it's the same thing in Dutch, is a part of artificial intelligence that occupies itself with the interactions between computers and humans based on, and so this is a bit of a vague concept, natural language. The ultimate goal is to read, decipher, and understand human languages. So this is what we mean with natural language, mainly the language that you would use when you are talking to a human. We've had some forms of language understanding historically, but really even this language was adapted to fit computers. We would speak in monotone tones, right? We would give short commands, turn on lights, right? It was language processing, but it was very much a cleaned up version of language that was meant to make it easier on computers to understand what we are trying to say. New generation is all about natural language processing, is all about understanding everyday language without making a specific effort for computers. You see natural language processing every day. There are a lot of very advanced artificial intelligence applications in natural language processing, but we see it when we use our smartphones. Google search is very much a natural language processing application. Spam filters are a very interesting part. The fact that your mailbox is hopefully mostly clear of spam is due to advances in machine learning. And finally, something like an autocorrect, right? Something that you use to correct typos is also a natural language processing app. These are everyday uses. We will talk about a bit more advanced specific uses in a minute. Now, the reason that we are talking about natural language processing today, right? Why is this such a hot topic, right? We are talking about machine learning a lot, right? There's a general trend in the IT landscape that is very much concerned with new developments in machine learning. But on top of that, there is also very much a new wave in natural language processing. This is somewhere since 2019. We can argue about the dates all day long, but we noticed that since 2019, really the capabilities and demand for natural language processing applications has exploded. The big reason for that, I've mentioned it already, is machine learning. Machine learning, I don't have the time to go over it really in detail, but it basically boils down to what you can see in Dutch on your screen. Instead of writing rules, sort of trying to make up all kinds of logical structures in order to interpret language if there is an adjective before an adverb, all kinds of these kinds of rules. This is the old approach towards natural language processing. Today, we are not about writing the rules of language. We are trying to learn, or rather the computer is trying to learn the rules of language itself. So this is the machine learning approach. So by the way, machine learning is nothing new, right? Machine learning hasn't been invented in 2019. It's way older than that. It's became a lot more popular somewhere in the 90s, but really it's exploded since 2019 in our experience. So a bit of a technical detour, right? Because before we start talking about the applications of natural language processing, I do want to give you a bit of information of what makes natural language processing such an interesting problem to work on for AI in general. Because the big problem is, I often boil it down like this. How do you define a word without using words? Seems like a bit of a silly question, right? How would you define something without using the very thing that it's part of? But that is exactly the challenge that we are facing when we are trying to teach our language to computers. Right? You have a word, but how do you explain what this word means? Right? You need to use other words to do that. And in essence, you end up with a very complex interconnected web of concepts and words and adjectives, adverbs, all kinds of things, verbs, all meshed together in some kind of huge network. And this is what we know as language. This is a very complex thing. Right? We as humans are not smart enough to translate our language into a logical structure that computers can comprehend. What we want, in essence, is not words, but what we want is something that computers are a lot better at, namely numbers. We want to have some kind of system that translates words, right, things that we can recognize, but we don't really know how we recognize them, into a set of numbers that a computer can understand. And so this is the big idea behind word embeddings. Right? It's somewhat of a technical topic, but I'll try to explain. Let's say you have 10 different numbers to represent a number of different words. Let's not say all the words in the dictionary. You need a lot more numbers to do that. But we have, for instance, here the words cat, kitten, dog, and puppy. You want to express the relationship between these words. So you could define two numbers, right? Catness, the cat, how much cat-like properties does this object have? Catness. And youngness, how young is this? So if you were to use two numbers, right, if it's 0, 0, it's not a cat at all, and it's not young at all, it's a dog. If it's 0, 1, it's not a cat, but it is young, then it's a puppy. If it's 1, 1, it's a cat, and it's young, it's a kitten. Right, you understand where I'm going with this, right? These are 4 words. We need 2 numbers in order to represent the relationship between these words, and that's exactly what we are trying to do for the entire dictionary. One catch though, so these numbers, I call them the catness, the youngness of the word, sorry about that, about the word that we are talking about. We do not define these categories ourselves. We basically give all the words to a computer, right? We give them a lot of examples of how these words are used together. Then it's up to the computer to find an optimal set of numbers to represent the relationships between all the different words that are used by humans in everyday life. Computers can do this, right? This sounds like an almost impossible task, but it is exactly what computers have gotten really good in the past few years. And the interesting thing is that we as humans can use their numbers to even do math. You could say, for instance, that a king, so really you can do this in code, right? You can make a code environment that allows you to do exactly what I'm describing here. It's not a metaphor. You can say to a computer, what is the result of taking the word king, subtracting the word man, and adding the word woman? And this computer, if it has a well-trained word embedding system, will give you the answer queen. You subtract the concept of maleness, let's say, and you add the concept of femaleness, and then the computer knows, oh, we are talking about a queen. It's quite amazing for me that a computer can do something like this, but it works. It works. And how does it work exactly? Again, this is a very, very technical topic, but I'll boil it down to a few simple ideas. Basically, what we do is we take the entire internet. So this is BERT, by the way. This is a very popular modern machine learning system that is able to do natural language processing. And it was a huge innovation. It was developed by Google. It was released as an open source, namely a free thing for the internet to use. So it's become immensely popular. And it was basically trained using a very simple idea. Let's take a lot of data from the internet, really. We took almost the entire internet, the entirety of Wikipedia, for example. We take a bunch of data, and then we ask a computer to do one simple thing. We take a sentence, we remove one word, and we say to our computer, what do you think the missing word is? For, texts from all over the internet, right? This could be a text on biology, this could be a political rant, this could be a Reddit discussion, whatever, right? We take a sentence, we leave out a word, and we ask a computer to predict the missing word. Do this billions and billions and billions and billions of times, and you will get a computer that becomes pretty good at trying to, based on the context, determine what the missing word should be. This is exactly what how a word embedding works, how it should work, to be more precise. So this is the huge idea behind natural language processing today. We try to create a word embedding. We call this in a semi-supervised manner, right? We don't have to label every sentence. We can do this completely automatically. We can create a system that just spits out sentences and leaves out one word. We can do this billions and billions and billions of times. And then you have a language model that you can attach to a very small AI component. And then this language model will help this very small AI component to do a very specific task, right? Let's just say that you are Coca-Cola, company Coca-Cola, and you want to know what people are saying about your products, right? This is not something that this language model will do out of the box, but it is an amazing tool for an AI component who just wants to have a bunch of numbers that can do math with. It will help that do this very specific task using very little amounts of examples. Right? It catches on really quickly because it already has this number representation that it got from a model like BERT. Now, some of you might have heard already about a model named GPT-3. GPT-3 got a lot of attention basically because of this. When we talk about natural language processing today, it is mainly because somewhere down the line, people realized that we could scale these kinds of systems immensely. I already told you, we don't need to do supervised learning. We don't need to make these examples by hand, right? We can create an automatic system that spits out training data for our machine learning system. So somebody realized, okay, let's take this to an absolutely ridiculous scale. And that result has become GPT-3. So the company developed this language model using $4.6 million in computing power. The result of this language model is orders of magnitude larger than anything that was created before, and it can do some very, very interesting things. The most impressive trick is on one hand that it understands language in an almost creepily good way, right? It's very good at understanding language, but it also has a very neat trick, namely that it can generate language from itself. Using a very simple idea, you feed it the beginning of a sentence, and then you simply ask the AI system, what do you think the next word is? And then you keep doing it and keep doing it and keep doing it. And if you repeat this process, you can have the AI system write an entire text based on a simple prompt. Something like, a man walked into a room, he opened the door and he saw his fiancée in a pool of blood. And then he said, then you can say, go GPT-3, right? Finish the story. And it will do so very frequently in a very believable manner. It's actually quite creepy. So the very last slide will tell you a bit more about that. All right, so this is a bit more businessy, right? We've talked about some technical stuff first. Why would you invest in natural language processing today? On one hand, you have the automation part, right? You have an increase in efficiency. Computers do not sleep. Computers think at the speed of light instead of, like we humans do. So if you have a task that requires the use of natural language processing, then you can do it a lot quicker in a lot of cases on a computer than you would do it with a human. So automation, efficiency, that's a pretty obvious one. But in natural language processing, in communication tasks, let's say, it is also, we've also noticed that error reduction is also a very big part of the added value that an AI system brings. Right? If a human has to look at the same document over and over again and has to, copy a certain value from one field of the other to the other, the critical thinking disappears really quickly. Right? We humans are generally pretty bad at repetition. And if you have a task that has a lot of repetition, but does require a lot of, active thinking, right? You need to keep your head in the game to notice like this 1 in a million exception that could, cause a lot of problems. This is very difficult for humans to do. So this is also a very big sales argument when it comes to selling natural language processing applications. So third one is automation, pretty much the same thing. All right, it does have downsides. We should mention these straight away. First of all, these AI systems, they are able to process language, but they are not able to explain how they process language. In a way, they are very similar to humans, right? We humans, we use language, but we can't really, define it in very well-defined rules. It's a bit vague. AI system has a similar problem. I always say, like, if you would cut open the brain of a human and look at the brains, you would not see how this brain is processing language. It's a similar thing for AI systems. But this does mean that you have an uncertainty factor. The AI system does a job, it gives you a result, but you are not exactly sure if this result is 100% correct. Finally, if you want to do natural language processing properly, if you want to do AI machine learning properly, you need data. Open source, freely available natural language processing models do a lot of generic tasks out of the box. But if you want to do something specific, like recognize Coca-Cola products or whatever, you need to have some amount of data to teach the machine learning system this specific context. So you need this data. All right, natural language processing is used for a lot of tasks. Most importantly, classification. You have a text, you want to know, what is this text, right? Is this an order? Is this a complaint? Is this a personal message? Is this a document that's being sent to us, et cetera, et cetera, et cetera. This is standard, the baseline task for a natural language processing for any machine learning system, classifying data into certain subjects. Going a bit deeper, we have named entity recognition. What if you have a document and you want to know, for instance, what is the phone number? This is an order and you want to have the phone number of your contact person. It's written somewhere inside the document. You don't know exactly where. Well, this is what named entity recognition does. Sometimes you need optical character recognition. This is somewhat of a vague, it's somewhere in between computer vision and natural language processing. Mainly, you have a scanned in piece of paper and you want to recognize all the characters that are written on the paper. The computer can understand what's actually on the piece of paper. Speech to text, another one, sort of a connecting natural language processing task. Take speech, convert it to text. Once again, so the natural language processing algorithms can do their thing. Sentiment analysis is another big one. Basically, determining the emotions used in a piece of text. Very interesting on Twitter, for example, if you want to know whether or not people are positive about a certain product, certain service, etc. Finally, and this is somewhat more of a niche one, these days it's also possible to use very advanced natural language understanding to even summarize texts, to understand what a text is saying, to take the base information, the most important piece of information that's being conveyed, and to condense that down to a smaller text. It's something that machine learning systems have also gotten quite good at. Just a few examples of how we as Brainjar use natural language processing for our clients. One example is TVH, a machine rental company. Basically, they get a lot of emails with orders, right? I want to rent a crane next Thursday. Deliver it at this address, please. TVH had about 7 people working full-time on, looking at a mailbox, opening these orders, typing them over into the ERP system, right? Processing these documents completely manual. Very repetitive. These people were actually hired to do customer relations, so it was not their favorite job in the world. So we designed an application that, on one hand, does a lot of the processing completely automatically, but because we are talking about, there is an uncertainty factor, and we are talking about multi-million-dollar machines, in construction sites, you don't want to move you don't want to move deadlines too much, or your entire planning goes down. So we have an application that does most of the job completely automatically, but then presents the results to the end user. So the end user sees what information the AI system has extracted and where it has found this information in the document exactly. So this is a very handy tool for TVH. It gives them a lot of speed up, 80%, by the way, it's 80% faster than before. Gives them a lot of speed up, but it still gives them the human control that they want for, their absolutely crucial systems that you do not want to have any kind of computer error messing things up. Very similarly, we did this for HVW, the Hulpkast voor werklozen, I think it's called. So basically an unemployment agency. And they have these paper documents, opkaarten in basic Dutch. So unemployment forms that people need to hand in every month. It contains a calendar, right? This is a very non-standard thing that you find on a document, a calendar that can be filled in with all kinds of different values. And it contains some handwritten information like what's your name, what's your national social security number, basically the equivalent Rijksregisternummer in Dutch. So they need to fill in this information, and HVW had to process, I think, a few 100,000 of these documents every month. So once again, we created an AI system that, on one hand, does most of the processing completely automatically, but also presents the results side by side with the original information so that the human operators can still do a manual check to make sure, right? You don't want a computer system. These documents are important, right? People could get into a lot of trouble if our computer system would make some kind of unpredictable error. So it is very important to present these results and to have that final human in the loop before these results actually get finalized. All right, final example, by the way, I just want to mention this real quick. When we are talking about, natural language processing in a business context, of course, chatbots are also very important. Namely in retail, you do want to have some kind of communication link with your clients or other businesses, right? Sometimes there are some kind of standard interactions between other businesses that you want to handle automatically. And this is where chatbots really shine. Major up point when we are talking about chatbots is that you can create one chatbot and deploy it on all kinds of channels, right? You have smart speakers, you have your website, you have applications that you would want to use. You could be active on Messenger and respond completely instantly to customer questions. So, of course, chatbots are a very big part of natural language processing, very big part of business being generated by natural language processing. And of course, we should mention that we have a product. We have a chatbot creation platform called Oswald that does exactly this. So feel free to check that out. So this is the end of my presentation for the most part. Just one final thing, mandatory homework, basically, for all of you that came to listen to my talk. Basically, you need to visit AI Dungeon. So AI Dungeon sounds like a bit of a weird and sinister thing, right? But it is actually a very nice example of the generative power that these AI models are having, right? I described it before. You can give them a prompt, and it will continue this prompt completely automatically. Well, somebody took these models and trained them on choose your own adventure novels, right? Some of you might remember, right? You have like a little book and there's a troll in your way. If you want to fight the troll, go to page 174. If you want to run away, go to page 95, for instance. This kind of interactive storytelling, they fed this to a language model. And now you have basically the same idea, but completely open-ended. This is, if you want to see the future of storytelling using machine learning, this is the #1 application to convince yourself that AI is going to play a very, very big role in this future. Because you can simply say like, okay, I come to you are at the princess's castle, what do? Well, I jump on my magical dragon, fly to the moon. And the system will say, okay, you've arrived at the moon and now you see a crater landscape. You land on the moon, but there's no oxygen, et cetera, right? This system is working with the information that you are giving it and using it to tell a story together with you. It's interactive storytelling. For me, this was the eye-opener when it came to, you have the processing natural language, it's in the name, natural language processing, right? You take pieces of data and you process them to something more condensed further down the line. This is what classification does, entity extraction does as well. But the generative part of artificial intelligence, that is something that we have only just begun to explore. I'm very sure that next week, when Tim, I guess, we'll talk about AI and journalism, that this generative part of natural language processing will play a very, very big role. Okay, so that's pretty much the end for me. I hope you've enjoyed this little presentation. If there are any questions, I guess now is the time to let me know.